All right, so question number 4. What is the derivative of ln x? So this is a proof on how to derive ln x. And so the junior tutor provided a proof on how to do it. I'm going to provide a different one, and then I'll run through what the junior tutor did, okay? All right, so we're going to assume that we know, or that we already have proved that the derivative of e to the x is just e to the x, okay? So we're gonna assume that we already know that. So let's say that d to the dx of x, we know what that is, that equals to 1, right? Well, we also know that x can be written as e ln of x, right? So let's write this x as this. So d dx e ln of x. All right, that still equals 1, okay, because this is equivalent to x, okay? So this is technically a chain rule, right? And we know that the derivative of e to the x, or e to whatever function of the power, is equal to just e to the whatever power, right? So if we use our chain rule here, we'll get e to the ln x. And now we need to derive the inside function, right? Which is going to be ln x equals 1. But we also know that e to the ln x equals x. So this also equals e to the ln x equals x, and we have x times dx ln x equals 1. And if we isolate for this whole term here, we get d to the dx ln x equals 1 over x. Okay, so that's how you can derive ln of x, and this is the proof for it. So this is the proof. So the second proof, I'll run through what the junior tutor wrote. So let's start here. So they first said, okay, so y equals ln x, okay? And they're also using the same assumptions that we know that the derivative of e to the x is just e to the x, okay? So they said, okay, let's say y equals ln x, okay? Well, we can apply e to both sides. So e to the y equals e ln x. And they recognize that e ln x is just x. So they have e to the power of y equals x, okay? Now they're going to differentiate both sides. They're going to implicitly differentiate both sides. So that's should be x. So d to d dx ey equals d dx of x. Okay, they're going to differentiate both sides. Well, so if they implicitly differentiate, this is a chain rule again, right? So it's going to be e to the power of y times dy over dx, or y prime, I guess you can say, right? Because that's going to be the derivative of y. And here, you don't really need to implicitly derive because d to the dx of x just equals 1. Okay, so now they have dy over dx equals 1 over ey. But they notice that 1 over ey is just e to the ln x, or ey actually just equals x. So they're going to say this equals just x, right? And dy over dx can be alternatively written as d of dx ln x, because they just took this y, they noticed that we can actually derive y, which is just ln x, and now we have proved that the derivative of ln x equals 1x in 2 different ways. Okay, there you go. So this proof is correct.